Perfect. Okay, so hi, my name is Lisa. I work at Lithoz, where we make ceramic 3D printing. Everything started as a spin-off from the Technical University in Vienna, but it's now a full company. We have more than 100 employees all over the world, but our headquarters is still in Vienna, Austria. We have over 200 printers operating worldwide, and we're a technology provider. So we build the printers, we provide the software, and we provide the materials, but we do not customize the parts, we do not fabricate them. Our customers have applications in basically every industry you can think about. So we have a lot in medical applications, a lot in aviation, aerospace, but we also have a lot happening in research and development, and that is what I'm gonna then venture into later on in this presentation. Before I do that, I want to quickly introduce the technology itself so we all know what I'm talking about later on. As with all 3D printing processes, we start with a 3D model. We then do the 3D printing, and what comes out of the printer is actually a composite material. So we then have to put it through post-processing. So we have debinding and sintering, and then we get to the final ceramic part with all its unique properties. Good. So that's the printer, and inside the printer, we have a vat and a rotary plate that makes for an even surface for each individual layer. The material is dispensed automatically, and the vat itself has a transparent bottom. So when we go down below the vat, what we can see is the projector system. And here, because it's a layer-wise approach, each individual layer is projected onto the bottom of the vat using blue light. That's how we then build up the part, layer by layer. And the building platform comes from above. Good. Now we'll go into a bit more detail about that. So as I said, it's a layer by layer approach. So what we do is we have the 3D model, we put it into the printer, and the printer slices it into individual printing layers. That can be from 10 microns up to 100 microns, depending on the material and the settings you choose. We then have the projector system, where the blue light gets emitted onto the bottom of the vat, where we then expose the part layer by layer. The big benefit of that is it doesn't matter for the printing time if you just print one part or 15 if they fit on a platform. It doesn't change the printing process time. The material we use for printing is a polymer that is photocurable, and the ceramic particles are dispersed inside of the material. Then once the blue light exposes the layer, due to polymerization, it then solidifies and builds the part up layer by layer. As I said, once we take it out of the printer, it is composite. And we then put it to post-processing. So first we go up to, for ceramics, moderate temperatures, so below 1,000, and we burn out all the organic matrix. And then we go to even higher temperature, solidify the material, densify, we then have shrinkage, and after sintering, we do get to the properties that make ceramics such an interesting material. When all of that is combined, we have, because we have a 40 by 40 micron pixel grid, we can print in very high resolution, and we can do that all throughout the printing platform and from print shop to print shop, so we have a very good reproducibility. We have a variety of materials that we can print. I'm just gonna pick out a few for today, but if you have any interest in something else, please let me know. I have some samples with me. For example, we can print aluminum nitride. This is often used as a substrate material for heat sinks, for heat exchangers, all of that. And this is due to its very good thermal conductivity and its low